Welcome to solverfy.
Once again, welcome to a new problem. This time we're going to be dealing with two aspects of statistics. Well, actually one aspect. So statistics has two branches. It has quantitative statistics and well, actually not quantitative statistics, but it has descriptive statistics and inferential statistics. Under descriptive, you can always present visuals of your data through tables, numbers, and graphs. And the numbers include measures of central tendency and also measures of spread. So measures of central tendency and measures of spread. So these are two aspects of your data. So measures of central tendency and measures of spread. And then also when it comes to your graphs, you have quantitative graphs and qualitative graphs. So these are two types of graphs that you can come across. For quantitative graphs, these are numerical. And the numerical would include things like histograms, which kind of looks like bar graphs. We also have frequency polygons. And we also have the ogive. So the ogive is the ogive is the cumulative frequency. So the ogive is the cumulative frequency graph. So in our new problem, we're presented with data. The data has class limits, and it also has frequencies, meaning that between 60 and 64, and these are glucose levels in milligrams, glucose levels in milligrams. So in that sense, we have 60 to 64 to 65 to 69, one patient. So the frequency represents the number of patients in a medical facility, the number of patients in a medical facility. So we have 65 to 69, we have 70 to 74, we have 5, and then we have 75 to 79, we have 12, 80 to 84, we have 18, 85 to 89, we have 6, 90 to 94, we have 5, and then 95 to 99, we have 1. So in total, we're looking at 50 patients. And so in this problem, we want you to graph the histogram, the frequency polygon, and also the ogive. And on top of that, you want to tell us the range of glucose levels for the patient. So those are the pieces of information that you're looking at gonna simplify this problem by having bounds. So, taking the class limit and then introducing boundaries to the class limits. We want to introduce boundaries to the class limit. Of course, we need the midpoint, because without the midpoint, it's difficult to determine the exact point where the graphing is going to take place. And of course, finally, just like any other piece of data, you need frequencies. So just like before, we're going to have all these class limits that we mentioned earlier. And we have to highlight the results of the boundaries, and there's a formula to that. For example, if we want to get the lower bound, we're simply going to take the lower limit, which in the first case is 60, and then you subtract 0.5. And if we want to get the upper bound, we're going to take the upper limit of the classes of glucose levels, and then you want to add 0.5, and that simply means that this goes from 59.5 to 64.5, 64.5 to 69.5. We have 69.5 to 74.5. And the reason why we're doing this is so that we don't have bounds. So we don't want to have bounds. We don't want to have gaps between the histograms. So 79.5, 85, we still have to extend this, 90 to 94, 95 to 99, 84.5 to 89.5. You also have 89.5 to 94.5. We have 94.5 to 99.5. The midpoint is computed by taking the lower limit plus the upper limit, and then you want to divide that by 2. And so in that process, you can see why the midpoint is, as an example, you'd take 60 plus 64 divided by 2, that's 124 divided by 2, and that gives you 62. So we have all these midpoints coming up just based off of the results of that data. And the frequencies still stay the same, like we mentioned before. We need all this data to make sure that our histogram, our cumulative frequency graph, our ogive is making all the sense that we need. So once we have that, now we can draw a histogram. We can draw our histogram. So we do have the x-axis and the y-axis for the histogram. We can divide it into different portions. We don't have to start at 0. As you can see, if you go back to the data, it starts from 59.5. So we can divide our sections into relevant pieces of information. So 1, 2, 3, 4, 5, 6, and then 7 and 8. I think we need to extend that to make sure that our graph makes sense. So in the x-axis, we have the blood glucose levels, and each of these points is divided into subsections, so 59.5 to 64.5. So this should be 64.5 here. then 69.5, we have 74.5, we have 79.5, 84.5, 89.5, 94.5, and then we have 99.5. Then we have 5, those are the frequencies, 5, 10, 15. Then we're going to have 20. This is just the frequency. And now we can have our graph. This first one, we have 2. Then we have 1. Then we have 5. Then we have 12. Then we have 18. And then we have 6. And then we have 5. And then we have 1. And that gives us a total of 50. So all the histograms, they touch each other just to make sure that we don't have cases where we have gaps in between the stacks, the rectangular pieces that are standing. So that gives us the histogram that we're looking for. And so from this histogram, there's a trend that we kind of pick up, and it just so happens that the left side of the histogram, so we'll say the histogram is slightly left skewed. The histogram is slightly left skewed since the left tail is stretched relative to the right tail. So that's what you have right there. Sometimes left skew is also the same as negative skewed. Left skewed is the same as negatively skewed. We also want to have the cumulative frequency graph. So, we talked about that. We wanted to have the frequency polygon. So to compute the frequency polygon, we are going to use the midpoints. So in this sense, we're saying, frequency polygon, we need the midpoint. So we still have, x-axis, and we have the y-axis. We still have the partitions like before. So 1, 2, 3, 4, 5, 6, 7. And then 8, 9, and then 10. We still have the frequency on our axis, 5, 10, 15, 20. These are the frequencies that we have. We need our midpoint numbers. We have 62, 67, 72, 77, 82, 87, 92, so 82, 87, 92, and 97. So at 62, we have 2 up there, and then 1, 6, 7, 5, 12, 18, then we have 6, and then we have 5, and then we have 1. So those are the numbers we have, and so we're just going to start all the way down and connecting these dots. So these goes up, up, and they just go all the way up like that. Goes all the way up. And so this is our frequency polygon, and cumulative frequency. So this is, so we're looking at the frequency results of this table. And we can have tabulation of cumulative frequency, tabulation of cumulative frequency. In this sense, we have less than 59.5. We're not going to have cumulative frequency. We have our goal is to graph the ogive. I think we're going to have to do it a little bit below. We're going to have to do it a little bit below. And so there's a tabulation of the cumulative frequency graph. So we're coming back here, we're saying, well, we need a table for that. So we have an axis, these are 2 axes. This is an axis, and that's another one. This is cumulative frequency. And don't forget that on this axis, these are the blood sugar levels. So we have the blood sugar levels, and on this one we have less than 59.5, less than 64.5, we have 2, less than 69.5, we have 3, less than 74.5, we have 8, less than 79.5, we have 20, less than 84.5, we have 38, and then we have less than 89.5, we have 44, less than 94.5, we have 49, and then less than 99.5, we have 50. So the graphing simply means that we're going to take all these numbers and make sure that we represent our cumulative frequency graph, which is the ogive. And so on this axis we have, maybe we could do it below. We don't have to do it at the top right there. To do it right here. axis like that. And so we have blood glucose levels. And we have cumulative frequency. We have cumulative frequency. It goes 0, 10, 20, 30, 40, 50, 60, 70, 80, and so on and so forth. On this side we have 59.5, 64.5, 69.5, 74.5, and we have 79.5, 84.5, and we have 89.5, 94.5, and then we have 99.5. And then we have the accumulation. We have 2, 64.5. We are at 2, 59.5. We could start at the beginning. We have 2 and here. And then we have 3 at 69.5. They're so close to each other. Then we have 8. We have 20. We have 38. We have 44. And then we have 49. We should change this a little bit. We have 44 right here. And we have 49. And we have 94.5 and 49. And then we have also 50, something like that. So it's a graphing process where you have to be careful. If you're using software, it's way easier, but that's your cumulative frequency graph. And then we're going to say the frequency for 75 to 79 is 12. And the frequency for 80 to 84 is 18. So most patients have glucose levels that typically range from 75 to 84. So once again, we had a problem, and in this particular problem, we were given a class limit for glucose levels for different patients. We had 50 patients. We built up boundaries, lower and upper boundaries, midpoints, and the frequency tables. We used that to get our histogram, which is left skewed. And then we built a frequency polygon using the midpoints, as you can see. These are the frequencies. We built a frequency polygon using midpoints. And then, of course, we, besides the frequency polygon, we built a cumulative frequency table. And from using the table, we built an ogive. And determined the range to be between 75 to 84 for most of the patients. So I hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day.